quadratic equations today. Let's see, can I write the equation for a parabola if I know a few of the data points and I don't want to use the regression capabilities of my calculator? So let's begin with 3 points, 0, 0, negative 1, negative 2, and 1, 6. And we want to find the equation of a parabola in standard form that models those 3 points. So how are we going to go about doing that? Well, first of all, let's make sure we understand that this is x, this is y, this is x, this is y, this is x, this is y. We've got 3 sets of data where we have an x coordinate and a y coordinate. And we're looking to find that equation in standard form. So y equals ax squared plus bx plus c. Well, what we don't know at this point are a, b, and c. We've got 3 separate values for x and y. So we can find this model by setting this up as a system of equations. In our first point, x is 0, y is 0. So we can write a quadratic here that says 0 is equal to a times 0 squared plus b times 0 plus c. So let's make sure we understand what we did. We had the point 0, 0. 0 is x and 0 is y. So we took the standard form of a quadratic and substituted 0 for y and substituted 0 for both of our x's. And we can do this with all 3 of our data points. So our next one, x is negative 1, y is negative 2. My equation would be negative 2 is equal to a times negative 1 squared plus b times negative 1 plus c. And my last one, x is 1, y is 6, would be 6 equals a times 1 squared plus b times 1 plus c. And then we want to come back to all 3 of these and simplify them. Well, the first one is very simple because I got a 0 here and a 0 here and a 0 here. So if I simplify this whole equation, I get 0 equals c. It's going to make this very handy to solve the last part of it. Well, let's solve the second one. Let's simplify the second one. Negative 1 squared is a positive 1, and b times negative 1 is a negative 1. So I can rewrite this equation as negative 2 equals a minus b plus c. And then the last one, 6 is equal to a times 1 squared, a, b times 1 plus b plus c. Well, this system is simplified just by the simple fact that we know c is equal to 0 here. So if I make these 2 c's 0, I have a system of equations. Negative 2 equals a minus b, and 6 equals a plus b. Now, you can use any method you want to solve that system, but to me, the method for this particular one is kind of obvious because I've got a minus b and a plus b. Let's use elimination here. Let's add these 2 equations together. Negative 2 plus 6 is 4. A plus a is 2a. And negative b plus b, the b is eliminated. So a is equal to 2. I now know what my a value is. Well, I already knew what my c value was. My c was 0. My a is equal to 2. So how do I figure out what b is? Well, I can go back to either one of these equations. And if I know here that 6 equals a plus b, if a is equal to 2, well, what's b? If 6 is equal to 2 plus b, then it should be fairly obvious that b is equal to 4. So now I know the value of a, I know the value of b, I know the value of c. I can come back and write my quadratic with those plugged in. Y is equal to a, so 2, x squared plus bx, so 4x, plus c, so plus 0. And as always, a plus 0 at the end of your function is optional. I could write this as 4 is x12 is y. 10 is x12 is y. So let's write our system here. 10 is equal to a times my x value, 2 squared plus b times 2 plus b. I have taken 2, 10 and substituted 2 for the x's and 2 for the y. And we do the same thing for the next one. 12 is equal to a times 4 squared A, B, and C, and we can write our quadratic. Y is equal to negative 0.125 x squared plus 1.75 x plus 7. A, B, and C. So we can find these values. We can do this regression by hand using a system of equations. In the next video, we'll look at how to find this using our calculator and using quadratic regression. Not necessarily easier, but quite often faster, and that'll be the subject of our next video.